Yes, students, today we are going to start with exercise 14.3. Question number 1 is name any two figures that have both line symmetry and rotational symmetry both. So line symmetry and rotational symmetry, if you see the equilateral triangle, it's all the sides are equal. All the three sides are equal. So there are three line of symmetry also, and rotational symmetry is also three. So we can say that equilateral triangle as well as circle. Circle is also having infinite line of symmetry and rotational symmetry also, because we can rotate the circle in any direction. It will look like same. Okay, so these are the two figures which are having both line symmetry as well as rotational symmetry. Next is draw wherever possible a rough sketch of a triangle with both line and rotational symmetry of order more than 1. That means a triangle which is having line and rotational symmetry of order more than 1 is equilateral triangle. So you have to draw an equilateral triangle here. Draw this line symmetry in a equilateral triangle, children. A triangle with both line symmetry and rotational symmetry of order more than 1 is equilateral triangle. So draw an equilateral triangle and lines of symmetry in that equilateral triangle. Well, if you draw, all the sides must be equal. Parth Jain and Naman Jain, are you listening? Fiona, open your camera. Draw equilateral triangle . Draw an equilateral triangle, children, all of you, everybody. In first question, you have drawn line symmetry. Now draw rotational symmetry of an equilateral triangle. Draw these three triangles like this and make the arrows of rotational symmetry like this, and draw these points also, blue points, which I have drawn. First point will be here, second point will be on this side, and third point will be on this side. Draw it like this. A triangle with only line symmetry and no rotational symmetry of order more than 1. A triangle with only line symmetry and no rotational symmetry is isosceles triangle, which is having only line symmetry but not having any rotational symmetry. Write it down, children. A triangle with only line symmetry and no rotational symmetry of order more than 1 is isosceles triangle. So draw an isosceles triangle and draw line symmetry in that. Because there is no rotational symmetry, so there will be no diagram of rotational symmetry in this. So you have to draw an isosceles triangle with two sides equal and one side unequal, and draw line symmetry from in this triangle. In C part, it is given that a quadrilateral with rotational symmetry of order more than 1 but not a line symmetry. So a quadrilateral with a rotational symmetry of more than 1 but not a line symmetry is not possible to draw it, because a quadrilateral with line symmetry may have rotational symmetry of order more than 1 but not more than 1, of order 1 but not more than 1. Okay, so it's not possible to draw a quadrilateral. You write this answer. Next is a quadrilateral with line symmetry but not a rotational symmetry. So quadrilateral with line symmetry but not rotational symmetry of order more than 1 is a rhombus. So you can draw a rhombus here. Now next question number 3 is, if a figure has 2 or more lines of symmetry, should have rotational symmetry of order more than 1. If any figure is having 2 or more than lines of symmetry, it is having a rotational symmetry more than 1. Is it yes or no? Yes, Van Sharma. Is it yes or no? If any, yes, it is possible. Yes, if a figure is having 2 or more lines of symmetry, then it will have rotational symmetry more than 1. You can see the example of equilateral triangle also. It is having 3 lines of symmetry and it is having rotational symmetry also 3. So a square, center of rotation is intersecting point of diagonals, where the points are getting intersected. That is called center of rotation. Okay, that point is called center of rotation. And the order of rotation in a square is 4 times you can rotate it, and the degree is 90 degree. Yes, Kavya, it's correct. And in the rectangle also, the intersecting point of the diagonals, where both the diagonals are meeting, that center point is called the center of rotation. The diagonals where they are meeting, that is intersecting point of diagonals, is the center of rotation. And the order of rotation of a rectangle is 2, because either they are rotating on the length basis or the breadth basis. So it will be 180 degree. The angle of rotation will be 180 degree here. And in the rhombus also, the center of rotation is intersecting point of the diagonals. And again, the rhombus, all the sides are equal. So it will be, the order of rotation will be 2. The diagonals are equal in rhombus. So 180 degree will be the angle of rotation here. If we talk about equilateral triangle, are you listening, Tanvi? Equilateral triangle, again the intersecting point of medians, where the 3 medians are meeting in an equilateral triangle, that is called the center of rotation, and order is 3 times they are rotating and 120 degree. The angle is 120 degree when they are rotating. In a regular hexagon means all the sides of the hexagon are equal. Again, here also the intersecting point of diagonals is the center of rotation, and 6 order of rotation is there in a hexagon, because hexagon is a 6-sided figure. So its angle of rotation will also be 6, and 60 degree it will be moving. And if we talk about circle, then the center of rotation will be center only, and their order of rotations is infinite, and in every angle you can rotate it. And semicircle, midpoint of the diameter. If we talk about a semicircle, then it will be a midpoint of the diameter. Only one angle of rotation is there, and it is moving 360 degrees. So children, next question number 5 is, name the quadrilateral which have both line and rotational symmetry of order more than 1. A quadrilateral with both line and rotational symmetry of order more than 1 is square. Okay, so square is having both rotational symmetry as well as line symmetry. You can write down the answer, that square is having both line and rotational symmetry more than 1. This way you can draw a square, line symmetry in a square. Question number 5, line symmetry in a square, draw it. Draw a square and draw line symmetry in a square. And this is rotational symmetry of a square. Yatharth, Ayan. Draw rotational symmetry in a square. Next question is, after rotating by 60 degrees about a center, a figure looks exactly the same as its original position. At what other angles will this happen for the figure? So you can write it will happen. The other angles are 120 degree, 180 degree, 240 degree, 300 degree, and 360 degree. The figures is said to have rotational symmetry about same angles as the first one, and the figure will look exactly the same as it is rotated by 60 degree from the last position. Understood, children? So these are the angles through which we can draw it. Next is, can we have a rotational symmetry of order more than one whose angle of rotation is 45 degree? So the answer will be yes, we can have a rotational symmetry of more than one whose angle is 45 degree. And 17 degree, it's not possible for 17 degree. We cannot have a rotational symmetry of order more than one is 17 degree. Okay. So that's all for 14.3 exercise.